students, welcome back to my channel again. Today we are going to learn class 12's probability chapters binomial distribution, and this is the 11th session of the chapter probability. Now Bernoulli Trials, this particular topic has not been directly written in the syllabus of class 12, but for binomial distribution, if somebody knows Bernoulli's trials, then in my opinion binomial distribution conception will be more clear. So before we go to this main topic, we will do the topic Bernoulli trials. Now Bernoulli was the name of the mathematician. Okay, so by his name these type of trials have been given the name as Bernoulli trials. Now which are called Bernoulli trials? Trials of a random experiment are called Bernoulli trials if they satisfy the following conditions. So there are 4 conditions and the trials must satisfy those all 4 conditions, then only they will be called Bernoulli trials. Now trials means tossing a coin is a trial, throwing a die is a trial. So these type of things are actually trials. Drawing something from a box is a trial. Okay, so the conditions are there should be a finite number of trials. So obviously you can understand it. Okay, so the trials can be performed only in a finite number. The trials should be independent. Independent means each trial will have its own outcome and no outcome of no trial will be hampered by any other trial. Okay, that is independent. We all know that independent events. Okay, so if you want to check it again, you can go to my previous videos. Links will be given in the description box, so you can check out from that. Each trial has exactly 2 outcomes, success or failure. Now success or failure, you must be thinking that for a coin it is okay, but for die how it will be divided into only 2 parts, success or failure? Yes, it can be divided into 2 parts, success or failure. How? Suppose we are throwing a die. Then we are actually getting 6 outcomes, 1, 2, 3, 4, 5 or 6. Now we can take an event which will be called as success, that is suppose getting an even number. That means getting an odd number obviously will be failure. So getting an even number and getting an odd numbers, the success and failure's probability will always cover the full. That means 1. Okay, so probability of success plus probability of failure will be 1. The probability of success remains the same in each trial. That means Bernoulli's trials only will be handling with the same success in each trial. Like first we told that it must be independent. Now in each trial that success's probability must be same. Okay, now these Bernoulli's trial will be very much clear if we are just doing some example. Okay, look at this question that I have chosen for you. 6 balls are drawn successively from an urn or bag, you can say, containing 7 red and 9 black balls. Tell whether or not the trials of drawing balls are Bernoulli trials when after each draw the ball drawn is replaced and number 2 is not replaced. So there are 2 conditions given. First, where the balls drawn are being replaced, and the second one the ball drawn is not being replaced. Okay. So look, 6 balls are drawn. That means there are 6 trials. Okay. So 6 trials. So obviously finite. Now for finite, that means number 1 is satisfied. Okay. Second one, the all trials must be independent. Obviously independent, because first one and second one is not depending on each other. Okay, we can draw the ball, no problem with that. So we are doing for this one. Okay, we will be looking into this later. So this is for number 1. Obviously, because this is replaced, that means the second independent. So obviously that means they are independent. Okay, now coming to, so number 2 satisfied. Number 3, there must be 2 outcomes, success or failure. So we can take that getting a red ball is a success and getting a black ball is a failure. So that is also okay. The probability of success remains the same in each trial. That means getting a red ball, I told that this must be the success, so its probability, look, for the first trial, its probability is obviously 7 by 16. Now as the ball is replaced, so in the second trial also it will be 7 by 16. Third trial also 7 by 16. And in the same way, sixth trial also 7 by 16. That means in all trials the probability of getting a red ball is fixed, that is 7 by 16, same. So the fourth condition is also valid. That means if the ball drawn is replaced, then the 6 balls drawing this particular trials is Bernoulli trial. Okay. Now coming to not replaced part. 6 trials finite. Okay. For number 2 now. Okay, 6 trials finite. Independent, no, because whether we are drawing the first ball red or the first ball black, the second trial is depending on that. Okay, so independent, yes, independent, no, but finite, yes. So get now third one. Yes, third one is no problem. Third one is getting a red ball is success, getting a black ball is failure. Okay. Now probability of getting a red ball for not replacing part. First one is okay, 7 by 16. Suppose first one we are getting red ball drawn. Okay. Then second one will be 6 by 15. Third one will be 5 by 14, like this. Okay, so it will be decreased. And suppose black balls are done, then also the denominator will be changed. Numerator will be 7 always, but the denominators will be changed. In this way we can say that for not replacing criteria, we will get different probabilities of success in each trial. So this second criteria is not fulfilling the conditions for Bernoulli trials. So for first criteria, the drawing the balls are Bernoulli trials, but for second criteria, drawing the balls are not Bernoulli trials. Okay, did you understand this part? This is very easy, but for binomial distribution you need to know this. Now coming to our main topic, that is binomial distribution. So let us take an even that is experiment, that is a coin is tossed. So there will be 2 outcomes, success and failure. Success, suppose we are assuming that getting a head is a success and getting a tail is a failure. Let there are 8 trials and we need 1 success. Okay, you can change this also, no problem with that. So we need one success. So how can it be represented? 8 trials, those first can be the success, and we need only one. So first can be the success and rest all failure. Like the second success, rest all failure, third success, rest all failure, and so on. First all 7 failures and the last one is the success. So for 8 trials, for one success, we can represent the trials and its results in 8 CU1 cases. That means 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can represent it in 8 cases. Similarly, suppose we need 2 successes. Then how? If we need 2 successes, that means 6 failures will be there. Okay, that means number of cases will be 8C2. 1 success for 8 trials, 8C1. 2 successes for 8 trials, 8C2 is equals to, you all know, combination formula, that is 8 factorial divided by 2 factorial and 6 factorial and so on. Because if you need 3 successes, then obviously 5 failures. So everything is very clear here that if we need 2 successes, then it will be 8C2. Okay. So we can say that this can go up to maximum 8 number of successes. That means in 8 trials, maximum 8 number of successes. So max number of successes can be 8. Now look, for 1 success we have got 8C1, for 2 success we have got 8C2, 3 success, 4 success and so on, 8 success. So don't you feel that this will be a very lengthy calculation? So just to avoid these lengthy calculations, we will be using the formula related to n Bernoulli trials, and that is actually been derived for this particular binomial distribution part. Now look, there success and failure. So probability of success we are just giving the name as small p, and probability of failure we are giving the name as small q. Now already I told for Bernoulli's trials, success and failure, only these two will be the outcomes. That means P of S plus P of A must be 1. So we can say P plus Q must be 1. That means P will be 1 minus Q, or you can say that Q will be 1 minus P. So just to take only P, not the Q, so we can say that suppose there are Bernoulli trials, 3 Bernoulli trials. We are doing it with 3 Bernoulli trials, not more than that. Okay. So with 3 Bernoulli trials, suppose its success probability is P and its failure probability is 1 minus P. Then we can have its sample space like this, either 3 successes or 2 successes. 2 successes can be written like this. Okay, so 2 successes in this way. Then suppose 1 success and 2 failures like this. 1 success and 2 failures. So in this way, and the final possibility is all 3 are failures. So there are 8 possibilities. Okay. So we can say that number of successes, if that's the random variable x. Random variable already we have done. So random variable x, and that is number of successes. So what can be its possible values? X can have the values 0, 1, 2, maximum 3. Now probability of x, probability distribution of random variable already we have done. If you want to check the video, you can go to my description box, we'll get the link. So P of x, 0. How many are here? 1. In this particular point there is no success. So this will be, what will be this? Actually this is P of FF. P of FF F. Okay. Now look, all three are failures and they are Bernoulli trials, that means they are independent. Okay. So failures, that means we can write Q into Q into Q. So it's Q cube. P of independent, that means P of F into P of F into P of F. Okay. We have taken P of F equals to Q. So we can write Q into Q into Q. Right? So this is Q cube. For P of X, that means X equals to 1. We need to find it out. X equals to 1. This one and this one. So we need to combine these three. This is Q, Q and P. That means ultimately PQ square. And there are three cases. So 3PQ square. Okay. It's 3PQ square. For X equals to 2, another three cases are there. And it will be PQ. That means P square Q. So 3P square Q. And for 3 successes, only one P. So it's P cube. You can see this. Now look at this. Don't you think that these particular expressions are quite well known? So students, now we can have the relation of those probability distribution table and this binomial expansion. Look at this binomial expansion. Q plus P to the power 3, and we all know that its expansion is QQ plus 3PQ square plus 3P square Q plus PQ. And in the probability distribution also we have got these 4 things. Now, therefore we can say that the probabilities of 0 success, 1 successes, 2 successes and 3 successes, how it will be? It will be, this is the probability of 0 success. That means term 1. This is the probability of 1 success. So it's term 2. Probability of 2 successes, term 3. Probability of 3 successes, term 4. Can you see a particular pattern? 0 success, first term, 1 success, second term, 2 successes, third term, 3 successes, fourth term. Okay. Now we all know that P plus Q is equals to 1 because success and failures probability always will give you 1. So we can write like this: P of X equals to 0 plus P of X equals to 1 plus P of X equals to in this probability distribution part, and we are getting finally it's 1. Okay, so this is verified because it is probability distribution of random variable. It must be verified. So we have verified it. So we can now take generally for n trials and x number of successes. This was for 3 trials. We had 4 cases. So for n trials, we will have n plus 1 cases. Among them, we are taking x successes. How can it be generalized? P of x equals to x is, look, P of x equals to 0 is the first term. So P of x equals to x will be the x plus 1/8 term. The next term actually. Look, this is x. So here it will be x plus 1. As we have just taken this P of, this is T1, 0 and 1. So here it will be x and x plus 1. And which expansion? Expansion will be in Q plus P to the power n, not 3. That was example. Now we are doing generally. So this is n. Okay. We all know from binomial theorem that x plus 1/8 term of this binomial expansion will be NCX q to the power n minus x into p to the power x. Okay, this is from binomial theorem, we all know it. Therefore, we can say that probability of number of successes as x, that means x equals to ncx. P I am writing first, p to the power x, q to the power n minus x, equals to, normally this capital X is being omitted, so we can write it as p of x, where x equals to 0, 1, 2, dot 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 up to n. This x number of successes can be 0 success, 1 success, 2 successes, and up to n number of successes. And q, probability of failure, so that will be 1 minus probability of success. Okay, these are general notations. Now this p of x means this one. P of x is called probability function of binomial distribution. This is called probability function of binomial distribution. So we need to look at how many trials we are performing and how many successes we want to get. Okay, now this probability function of binomial distribution with n trials and probability of success with p is denoted with capital B of n comma p. Okay, so this is all about today's session depending on binomial trials and binomial expansion. I hope you all have understood the concept very well, and now you can apply this concept in the coming exercise. So in the next session we will be doing mean and variance of random variables. So till then, have a good day. Bye bye.